It is time again to dive into the wondrous and thriving ecosystem that exists under our very noses. Today, we will be studying 3 female Homo sapiens in their natural environment. The slumber party. These girls are exploring the thralls of adolescence. Let us observe.
We interrupt this program with a life-changing product. Introducing the latest in rating technology, the Boogie Board. Draw pictures, take notes, learn chemistry. Now only $99.99. Call now and we'll throw in a second one free. That's 2 for the price of 5. Call now at 696-696-6969.
Guys, I have an idea. Let's play Truth or Dare.
Shall we? Truth or dare?
Truth.
Who do you like?
No. Dare.
Fine, I dare you to answer the question.
Oh my god, okay, but you guys can't tell anyone. Don't worry, Shelves. Pinky swear. Okay, I have a crush on this guy, and his name's Avogadro, and he's Italian. Wait, who's Avogadro? Anyways, guys, he totally gave me his number.
I know, let's prank call him.
Okay, his number is 602-214-1990000000000000. Holy moly, that's a big number. That's right, Trixie. The number 6.02 times 10 to the power of 23 is called Avogadro's number, which is named in the honor of Amido Avogadro di Corango. The mole is a unit symbolizing a specific amount of anything, but in chemistry, a mole of a substance represents 6.02 times 10 to the power of 23 representative particles of that substance.
Are you sure he didn't give you a fake number?
No, he definitely didn't. Prove it. Well, let's check the phone book. I have it right here.
Wow, his number is really complicated.
No, it's actually very simple. Any particle that has X number of moles has X times 6.02 times 10 to the power of 23 atoms. So simply put, number of particles equals number of moles times 6.02 times 10 to the power of 23. Take element X for example. We know that the number of particles in element X is equal to the number of moles of element X multiplied by 6.02 times 10 to the power of 23. So if we had 3 moles of element X, you would have 3 times 6.02 times 10 to the power of 23 atoms of element X. So if element X was aluminum, we would have 3 times 6.02 times 10 to the power of 23 aluminum atoms.
Well, you know what they say, Shelby. The way to a man's heart is through his stomach.
Oh my gosh, give him a lemon.
Oh my god, Trixie, that's a lime.
You think he'll like it though?
Here, I'll try it for you.
Have you guys ever wondered what's in a lime?
Oh girl, that's simple. A lime is made up of water and glucose molecules. So water's chemical formula is H2O and the chemical formula for glucose is C6H12O6. Knowing the mass of the lime, you are able to easily find out how many moles of the particles are in this lime. You first need to find the molar mass of the compounds water and glucose. Recall that molar mass refers to the sum of the atomic masses in a compound expressed by grams per mole. We're going to find the molar mass of H2O. To do this, we know that we have 2 hydrogen atoms and 1 oxygen atom. So we know that the molar mass of hydrogen is 1.008. We multiply that by 2 and we get 2.016. Same thing applies for oxygen. We know that the molar mass of oxygen is 16. And there's only 1, so you just multiply it by 1. And so the oxygen's total molar mass would be 16. When you add both of these values up, 16 plus 2.016 equals 18.016. And thus, this is your given molar mass for H2O. So if we look at the molecule of C6H12O6, we have 6 carbons, each having a molar mass of 12.011. When we multiply 12.011 by 6, we get 72.066. Same thing applies for hydrogen. We have 12 hydrogen atoms, each having a molar mass of 1.008. When we multiply that by 12, we get 12.096. Lastly, we do the same thing with the oxygen. So we have 6 oxygens, each with an individual molar mass of 16. Multiplied together, we get 96. When we add these three values up, we get an entire molar mass of 180.162 for the molar mass of glucose. The molar mass of H2O plus the molar mass of C6H12O6 gives you a value of 198.172. Given that the mass of the lime is 30 grams, we can plug these values into the equation. Number of moles equals the mass in grams divided by molar mass. 30 divided by 198.172 equals 0.151. Therefore, there are 0.151 moles of particles in the lime.
Nah.
There.
I wonder how many oxygens are in this. Do you think I'll gain weight?
You mean calories?
No, I mean oxygens.
That's a valid question, Trixie. So to find out the number of oxygens in your H2O molecule, we're going to be finding the percent composition of oxygen. So we know that in the molecule of oxygen, we only have one oxygen atom. This oxygen atom has a molar mass of 16. When we divide 16 by the entire molar mass of water, which is H2O, we divide 16 by 18.016 and we get the percent composition of oxygen being 88.8%. The percent composition of oxygen is 88.8%, which means that you subtract that by 100 and the percent composition of hydrogen would be 11.2%. So when we're trying to find the empirical formula, we're going to say that 100 grams equals 100%. This means that we have 11.2 grams of hydrogen and 88.8 grams of oxygen. Next step is to find the number of moles. To do so, we find the mass divided by the molar mass. For hydrogen, we have a mass of 11.2 and we divide it by the molar mass of hydrogen, which is 1.008. That gives us the number of moles of hydrogen being 11.1. Same thing for oxygen. We have 88.8 grams of oxygen and we divide that by the molar mass, which is 16, and we get a number of 5.55. The next step is to divide both your H and your O by the smallest number of moles. In this case, the smallest number of moles is 5.55. So we divide 11.1 by 5.55 and 5.55 by 5.55. So for hydrogen, we get the number 2, and oxygen, we get the number 1. This means in every water molecule, there are 2 hydrogen atoms for every oxygen atom. Oftentimes in science, chemical formulas can be shortened for their most simplest whole number ratio. For example, glucose, which is C6H12O6, empirical formula would be CH2O. The empirical formula is simply the formula giving the proportions of the elements present in a compound, but not the actual number or arrangement of the atoms. Using the empirical formula, however, we are able to verify the actual number of atoms by finding the molecular formula. The molecular mass of H2O is 18.016, and we can use this to find the molecular formula. So the molecular formula is a formula given the number of atoms of each of the elements present in one molecule of a specific compound. We simply take the molecular mass and divide this value by the empirical formula's mass of H2O. So in terms of H2O, both the molecular mass and the molar mass are 18.016. When we divide the molecular mass of 18.016 by the molar mass of 18.016, we get a whole number ratio of 1. This means that the molecular formula would be H2O. Complex example in molecular formulas, we can take glucose, which is C6H12O6. If we had calculated the empirical formula, we would have found that glucose's empirical formula is CH2O. Knowing that the molecular mass of glucose is 180 grams per mole and that the molar mass of the empirical formula CH2O is 30 grams per mole, if we take the molecular mass, which is 180, and divide it by the empirical mass, which is 30, we will get the number 6, which means that the molecular formula of glucose is 6 times every atom in CH2O, giving you...
You breathe oxygen, right?
Oh no, I'm gonna get so fat.
This poor species meanders through life trying to avoid the pitfalls of natural selection and thus turns nature's will savage as it is beautiful.